Good morning, guys. Today, we will perform experiment number 5. What is experiment number 5? So, experiment number 5, this is BJT biasing circuits. So, what are the objectives and the intended learning outcomes for this experiment? Objectives. The activity aims to determine basic characteristics of BJT biasing circuits. Intended learning outcomes, the student should be able to analyze the operation of emitter-stabilized bias circuit and the three regions of operations of transistors. Analyze the operation of voltage divider bias circuit and determine the circuit, the effect in the output of the improper biasing of transistor bias circuit. So we discussed this one in our lecture about the biasing circuit for BJT. We discussed the fixed bias, emitter stabilized bias, voltage divider bias, and the miscellaneous bias circuit. So we need to use today, and we will connect it using the procedure from the experiment manual that we have uploaded with our canvas. Check the manual, check the procedure in the experiment. Okay, let's start with activity number 1. Activity number 1, this is an emitter stabilized bias circuit. We need to connect the circuit about the emitter stabilized bias circuit. So this will be our circuit to connect the emitter stabilized bias circuit. So we need to connect this emitter stabilized bias circuit. We need to use 8-volt supply BCC, RB of 1 mega ohms, have RC potentiometer 20 kilo ohms, a transistor 2N2219, or maybe you can use 2N22 ohms. Use almost 4 digital multimeter. So let us connect this one. So we need a supply. We need transistor 2N2219 BJT NPN. 2219. This one, the 2219. Next, we need 3 resistors. 1, 2, 3. Then we need grounds. 1, 2, 3. Check the circuit. So 2219. We have potentiometer. So we need to use RC, not resistor, at potentiometer 20 kilo ohms. So we need to replace this one to with potentiometer. Potentiometer. think we have a complete set. So we need 8 volts supply. We need to repeat this one, 2 or 3. We need R1, 1 mega ohms, which is 1M. R2, which is potentiometer, that is 20 kilo ohms. 23. So the increment 0.1. Then R3 is 330 ohms. 330 ohms. We need to put 4 meters, digital multimeter. We have meter 1, cross the collector meter. We have meter 2, base voltage. Base voltage, this one. Next, we have meter 3, meter voltage. Next, meter 4 is collector voltage. I think this now is complete. So let's read the procedure. So we need to connect the circuit. So figure 9.1. So adjust the supply to 8 volts. Okay, we have set the 8-volt supply. Then we need to use DMM. So from the procedure, we need to set the collector emitter voltage to 7.8 volts by adjusting the potentiometer. So adjusting the potentiometer, so that the collector emitter voltage must be 7.8 volts. So for this one, we need to adjust potentiometer R2. And we need to open meter 1. So which is the collector emitter voltage. Double check the value. 1 meg, 20k, 330 ohms, 2M, 219. 8 volts. So procedure. Using the DMM, measure the base voltage, the collector voltage, and the emitter voltage. Record your data in table 9.1. The transistor is in, so we need to determine the condition of the transistor if it is saturation, cut off, or in the active condition. So the first settings is the BCE should be 7.8 volts. 7.8 volts. So we need to adjust. We need to adjust the resistor R2. So this is not yet 7.8. How about 0%? 7. So this one is the most value for this one. 7.628. So we cannot adjust this one. So that will be our maximum value. So we can record this one. From the procedure, it is 7.8, but we need to use 7.628 volts. So, okay, so the voltage BCE is 7.628 volts. So instead of 7.8, we will use 7.628 volts. So we need to measure BB, BE, and BB, BE, and BC. So we need to record this one. So BC, so from the table 9.1, BB is BCE is 7.628 volts. Then BB is meter 2, that is 0.996 volts. Then the collector, that is meter 3, so 8 volts. Then we have the emitter, which is meter 3, that is 0.372, 0.372 volts. That will be the condition of the transistor. Next, we need to adjust the value of the potentiometer, this one, so that the meter 1 should be 4 volts. 4 volts. So, press A, 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 shift A. So that will be almost 4 volts. So we need to record again BB, which is 0.91. So 0.91 volts. Next, BC, meter 4, 4.287. 4.287 volts. And then the emitter voltage is meter 3, 0.286. 0.286 volts. And we need to determine the condition of the transistor. Next, we need to adjust the potentiometer so that the voltage is almost 300 millivolts. This one, 300 millivolts. Almost. Press A, press A, press A, press A. Shift A. Shift A. So this one almost 300 millivolts. So base voltage 0.82 volts, 0.82 volts. Next, the collector voltage is meter 4, 0.5 volts, 0.5 volts. Next, the emitter voltage is 0.2 volts, 0.2 volts. So what will be the condition of the resistor? So let us see. Adjust potentiometer so that the range is 4 volts and 0.3 volts. So we are through with this procedure. Then record the data on table 9.1. So we are through with that procedure. So that is the end of activity 1. Next, this one. So this one is the data, the only data for activity 1. Next procedure is to connect activity for activity number 2. For activity number 2, you need to connect the voltage divider bias circuit. So for this procedure, you need to connect this circuit. So connecting this circuit, let's connect this one. So we need 8-volt supply, R1 100K, R2 20K, R4 4.3K, and R3 is 1K. We need to share the multisim again. So close this one, close, close, close. So we need almost all of this one. So I will create a new one. Just copy paste the first circuit, and I will delete the other components. So deleting this one, same 8 volts, different R1. We need R2, which is also a resistor. We need R3, a resistor, not a potentiometer. So this will be the connection. Voltage divider bias circuit. We need a ground. We need to change the values. So what are the values needed? So we need 8-volt supply. R1 is 100 kilo ohms. So this one should be 100 kilo ohms. Then we need R2, 20 kilo ohms. This is 20K. Then I need 1 kilo ohm R3. 1K. Then R4 is 4.3 kilo ohms. This is 4.3K. Then same meter. Meter 1, ECE. Meter 2, base voltage. Meter 3, collector voltage. So nagkapalit. So meter 4, then meter 3. So same din naman. So we need to set the supply 8 volts. Then we need to measure BCE, BB, BC, BE, and BBE. So miss 1, 2, 3, 4. From the table we have 5. BBE. So we're missing NM. So we need to measure BBE. BBE base, and then emitter. Volts or values of 100K, 20K, 4.3, and 1K. So this is just measuring all the 5 values, then we will record all the data. Just that one. Okay. So we'll start with BCE. The value is 4.627. So 4.627 volts. Next, BB is 1. BB. So BB is 1.248. 1.248 volts. Next, BC collector is 1 meter 4. So meter 4, 5.304. 5.304 volts. Next, BE. Meter is 1 meter 3. So 0.632. 0.632 volts. Next, we have BBE. 1 meter 5. 0.615. 0.615 volts. So we are through. We are through with activity 2. Not yet. Okay. So this time, we need to add function generator. This one. Replace daw yung mga values. So we need to connect this circuit. Part of activity 2, which is to connect this circuit. So connecting this circuit, so we need to add 50 kilo ohms potentiometer. Then this one. $20K magiging 20K naging 10K. Then in series with 50 kilo ohms, then we need 47 nanofarad and 470 nanofarad. So this one. Then we need to set, okay. Sorry. This is this one. So we have additional 50 kilo ohms potentiometer. Additional 50 kilo ohms potentiometer. We have C1 470 nanofarad. We have C2 470 nanofarad. Then we added a function generator. So not yet set first. Then we have the oscilloscope. This one. We connect the oscilloscope at the input and at the output. Then we have meter 1 connected across collector and emitter. So let us set first the, sabi niya, from the procedure. Be sure all connection are properly placed. Yes, it is properly placed. Then the supply is set to 8 volts, same value. Then we need to set the DMM, open the DMM. Then the function generator must be set to an amplitude of 1.6 volts peak to peak. So meaning this is correct, 800 millivolts peak. Because the peak-to-peak input for the function generator is 1.6 volts peak-to-peak. So meaning we need to set the peak value to 800 millivolts. Next, open the oscilloscope. Open the oscilloscope. Then from the oscilloscope, AC coupling, this one AC coupling and this one is AC coupling. Then we have 2 volts per division. 2 volts per division, this is correct. Next, the time per division is 500 microseconds. This one, 500 microseconds. Next, the run. click the run. May nakalimutan tayo i-stop. Kaya yan, ito ba yun? May nakalimutan i-stop. Ito. Kalimutan natin. Okay, this one. So let us proceed. Sabi niya, click run. Okay, it is running, but based from the procedure, adjust the potentiometer, set BCE is 3 volts. So if BCE is 3 volts, what will be the output voltage? So this is BCE. So we need to set to 3 volts. That's A, or shift A. Shift A. Oops, sobra. Shift A, shift A, shift A, shift A, shift A. Shift A. AA. BCE should be 3 volts. Oops. And AA. Siguro almost na yan. Okay, almost 3 volts. So we need to get the output waveform. So we need to get the output waveform. Ano sabi niya? Measure BCE, yun na nga 3 volts, then record the output waveform. So record lang natin. Record the output waveform. So this will be the output waveform. Snipping tool. This will be the output waveform. So we have a clipping sa ilalim. May clipping siya. We have a clipping signal at the bottom. So next, we need to set BCE to 4.2 volts by adjusting again the potentiometer. So adjust the potentiometer so that the BCE is 4.2 volts. 4.2. 4.2. 4.2. Oops, small na. 4.2 volts. Oops, baliktad na naman. Shift A. Shift A. Shift A. Shift A. Shift A. Shift A. Oops. A. A. Sunod na malapit. A. A. Malapit na. 4.2. malapit. Okay, so for this one, we need to get the waveform. Snipping tool again. Then we need to measure, we need to get the waveform for 4.2 BCE. Take note the BCE is DC. This one is the AC output waveform. Next, we need to adjust again the potentiometer. Next, we need to adjust again the potentiometer so that the BCE is equal to 6.4 volts. So adjust now. I think this is 0%. 6.4 volts. So AA, 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 AA. So yun ang papalapit. 6.4. Shift A. Shift A again. Okay, 6.4. Then we need to have the screenshot. We have now again a clipping at the upper part of the waveform. So that will be our final waveform. So we are through with activity 2. We are now through with activity 2. So I will give you, or you can screenshot this video so that you can get the waveform. So this one. So I will give you time to have a screenshot for this waveform. So this one will be repeated twice. This video will be repeated twice so that you can get all the values. For this time, I will show you some of the output. So if you did not get this waveform, this will be repeated and I will give you the summary of this data. Okay, I will just summarize. So this one, stop sharing. Then I will show you the doc files. So this one, this is the recorded data. So for activity 1, this is data for activity 1. Paste. Then is this one to this one. Okay, we have now the data. Next, that is for the first table. Next, we need the data for the second table, which is this one. Okay, this one. So this will be the data for this table. So this will be the data for activity 1. You can screenshot this data. 1, 2, 3. Next, this is the waveform for 3 volts BCE. The BCE is the DC value, and this one is the waveform. We have a clipping at the bottom of the output waveform. The red is the input waveform, and the blue is the output waveform. The output, we have a clipping. Next, we set the potentiometer so that the BCE is 4.2 volts. So this is the output waveform. The blue is the output waveform. The red is the input waveform. Based from the output and the input, bumaliktad yung output natin. We have 180-degree out of phase. Okay, you can have the screenshot. Next, the last one, we have to record the waveform. If we set the BCE is equal to 6.4 volts, 6.4 volts BCE. This is the waveform. The output waveform is the blue. We have now a clipping at the top portion of the waveform. So you can see now the effect of adjusting, or you have an incorrect position of the Q point BCEQ. The BCEQ should be at least half of the supply. Our supply is 8 volts. When BCE is near the 8 volts, we have a clipping. When BCE is near the 0 volts, we have also clipping. But if we have a BCE that is almost half, is one half of the supply, we have a good output waveform. So that will be the end of our experiment. That will be the end of our experiment 5. Thank you. See you on experiment number 6.